All right, today we're pulling back the curtain on the invisible architecture that runs pretty much everything you do online. It's the hidden magic that makes your digital life possible, and we're going to break down exactly what it is and how it all works. Let's get right into it. I mean, seriously, have you ever stopped to think about that? You can be ordering food, streaming a 4K movie, and checking your bank account all at the same time. How on earth do these incredibly complex services feel so smooth, so instant, and so reliable? Not just for you, but for millions of other people using them at the exact same second. Well, the answer is a really powerful, really cool idea called a distributed system. And that's what we're going to unpack today. What it means, why we even need it, and the unbelievable challenges that had to be solved to make our modern world a reality. To really get why our world works the way it does now, we have to rewind the clock, because it wasn't always like this. For decades, from about 1945 all the way to 1985, computers were these giant mainframes. We're talking room-sized, incredibly expensive machines. A big company might have just one or two, and since there was no way to connect them, they were basically their own isolated digital islands. But then, in the mid-1980s, everything changed. Two massive breakthroughs happened at almost the same time, and they created a kind of big bang for computing that completely reshaped our world. So first, you get these powerful new microprocessors that cram the power of a giant mainframe onto a tiny, affordable chip. And second, we invented high-speed computer networks, which let these new, smaller computers talk to each other incredibly fast. It was, the absolute perfect storm. And to give you a sense of just how insane this leap was, check out this quote. The improvement in computer price and performance was just staggering. There's nothing else in human history that has ever improved that fast. It's what made everything that came next possible. So, this completely new idea pops up. Hey, instead of relying on one super expensive giant computer, why don't we just use a whole team of these cheap, powerful little computers working together? It sounds pretty simple, right? But here's the catch. Connecting computers is the easy part. Getting them to actually cooperate reliably as if they were one single brain, well, that turned out to be a whole different and way, way harder problem to solve. And that brings us right to the first huge challenge of any distributed system. It's called the agreement problem. How in the world do you get 100 or 1,000 separate computers to all agree on what the truth is at the exact same time? The official term for this is consistency. And it's a non-negotiable guarantee that no matter which computer in the system you ask a question to, you're going to get the same correct answer. Think about your bank. Every single ATM everywhere in the world has to agree on your exact account balance. There is just zero room for error. Here's a great example: booking a trip. The airline's computers and the hotel's computers are two totally separate systems. But for your booking to actually go through, they have to coordinate perfectly. They have to agree that, the flight is booked and the room is booked. If one says yes and the other says no, the whole thing just falls apart. And the consequences, if you don't solve this problem, they're a disaster. You could literally have two different people booking the exact same seat on a flight. Money being sent from one account to another could just, poof, vanish into thin air. So consistency isn't just a nice feature, it's the absolute bedrock of trust in our entire digital world. Okay, so all the computers have to agree. Got it. But that immediately leads to the next giant problem. What happens when some of those computers just fail? They crash, the power goes out, they go offline, because they will. And this is where fault tolerance comes in. The whole philosophy of a fault-tolerant system is that it's designed from day one with the absolute expectation that things are gonna break. You assume hard drives will fail. You assume networks will drop. You plan for failure so that when it happens, the system can just handle it and keep right on running smoothly. So how do you actually do that? Well, one of the most basic foundational techniques is something called stable storage. And it's a really elegant idea that all comes down to that old saying: never put all your eggs in one basket. Here's how it works. Instead of writing a piece of data to just one hard drive, the system writes the exact same data to two separate drives. It writes to the first one and confirms it's okay, then it does the same for the second one. That way, if the computer crashes halfway through or one of the disks physically breaks, it's no big deal. The system can just use the other one as a backup and recover without missing a beat. So simple, but so incredibly powerful. This whole challenge of getting a group to agree on a plan when some members might be unreliable or even malicious, there's a famous thought experiment for it in computer science. It's called the Byzantine generals problem. Picture a bunch of generals surrounding a city. They all have to agree to either attack or retreat at the same time. The catch? Some of their messengers might be traitors, carrying fake orders. So how can they ever trust each other enough to coordinate? It's a perfect metaphor for the challenge these systems face every day.
So let's bring this all back. These two enormous challenges, getting everyone to agree, which is consistency, and being able to survive when things break, which is fault tolerance, and all the brilliant solutions that have been invented to solve them, that right there is the invisible foundation of our entire digital lives.
So that seamless, instant, always-on experience you have on your phone, it's not magic. It's not an accident. It is built on top of this massive, complicated, and incredibly resilient distributed system that is working nonstop, completely behind the scenes to make it all happen.
So what are the main things to remember here? First, your apps aren't just one computer. They're run by huge teams of computers all working together. Second, getting all those computers to agree on your data, consistency, is a huge, constant challenge. Third, they are built from the ground up to survive failures. That's fault tolerance. And finally, all of this together is the hidden foundation that the entire modern internet is built on.
And that leaves us with one final thought to chew on. We take these incredibly complex, incredibly resilient systems for granted every single day. But as our world gets more and more connected and we become more and more reliant on them, it really makes you wonder, what happens when this invisible foundation is truly put to the test in ways we haven't even thought of yet?